Hey, what's up, fellas? Doing a little update for Richie in California. This is an autoclave boiler that's designed specifically to handle untreated water and to run on liquid fuels like waste cooking oil or diesel fuel, stuff like that. This section right here is the boiler and the steam heater. This is a zero pressure boiler. It does not run at pressure, but it does have a steam superheater so you can get the steam above 212 degrees. And essentially what we have here is the boiler. This is a splash catch. The steam goes down inside this combustor cowling. Where it is superheated and will be ejected into the building. We're going to be putting a T-fitting on this exhaust duct that will have excess will be flowing out the side, and we're going to have a valve in there that controls how much gas goes up into the building as well. Some of this exhaust gas will be going into the autoclave to act as a supplementary heat. We're going to be running this thing like a sauna. We're not just going to try and heat the whole building with steam. That would be very expensive and kind of hard to do. So this will also give us a high thrust of air to consolidate the temperatures a little bit better. This right here is the auxiliary housing that contains the pump, the blower, and some other electronics and plumbing required to make this thing work the way it does. And we have a control box that is detached to keep you out of kicking distance of the machine, because when you're lighting it up, sometimes some flame may squirt out here or there. Hopefully not now that we've got this cowling, we should be good, but still, this will allow you to be away from the burner as you're running it and igniting it. It doesn't even have to be in the same room, which would be ideal. If this was blocked off with some block and stuff like that, or just something to keep it out of the wind and stuff like that. Now, ideally, we would have the rest of this wrapped with like some fiberglass welding blankets. But like all this tubing will get wrapped, and this outside here will get wrapped with insulation. But we'll probably let you guys do that on your end. It'd be real easy to do. I don't want to soak up a bunch of hours on you guys. So my main goal tomorrow is to fire this thing up and to become proficient at running it. I want to be able to walk up to it and light it up in seconds. And it's just like any new tool. You got to learn how to use it. But the problem with this tool is no one knows how to use it yet. So tomorrow, if the winds ever die down, that's going to be the goal. Is we're going to take this thing outside and we're going to establish a ignition procedure and an operating protocol. So this is where we are. This thing is finally done. This also has a PID controller attached to it that will be connected to an emergency shutdown in the event that we lose blower. That way we don't continue to just spray fuel, which could become a huge fire hazard. So it does have an emergency shut-off that's going to be driven by a thermocouple and not a flame eye, because I have found flame eyes to be actually ineffective. If the fuel continues to ignite, the flame eye will still see light. I didn't mean to make that rhyme. So I'm going to leave this here. I'm calling this done. This thing's ready to head to California. As soon as I test it, that is. We're going to definitely run some tests and be sure that everything's working out all right. I haven't cleaned it up quite yet because I'm going to get it dirty again. But it'll be interesting to see this thing running tomorrow. For any of you guys who haven't seen this, it does have a ball valve and float connected to this center section here so that it lifts out. It's one component. And the reason I did that is because this can be removed from this keg. Let's say 5 years down the line, this keg's just shot or burn up or gets a hole rusted in or whatever. That way we can just pull it right out and keep the main core of the machine without losing it. This keg should last indefinitely. It's just like a stainless steel pot you'll use on the stove, but just in case, I didn't want us to be trapped. This right here is a special splash trap that stops boiling splash and all that from escaping out the top here. Because if that were to happen, what we would get is, if we've got hard water in the tank and that hard water makes its way up through here, over time we'll get lime deposits inside of this thing. By the way, I do have a pressure relief valve on the way for this. It's just not attached yet. That will be getting connected. But even though it's at zero pressure, what could happen is, say 6-7 years down the line, that little bit of splash getting up in here might start to form calcium buildup in this superheater tube. It shouldn't do that now. We did see a drip every once in a while when we were running it in the first test, but I believe that to have been condensation from not having this upper section insulated. So I think we're good. I think we're in the clear. And I'm anxious to fire this thing up and get on down the road.